Okay, so now we have some miscellaneous exercises. There is only 8 miscellaneous exercises here. These are mostly word problems. We will have to draw some diagrams for them and solve the problems. So the first one is, if a parabolic reflector is 20 centimeters in diameter, so you have a parabolic reflector, and it is 20 centimeters in diameter, 20 centimeters in diameter, and 5 centimeters deep. 5 centimeters deep. You want to find the focus. Find the focus. So in order to do that, what you need to do, first of all, you need to know what a parabolic reflector is. And I don't really know what that is. So let me go over here and look up what a parabolic reflector. So a parabolic reflector is just like a it seems that it's a dish antenna, or a mirror, basically. So that's a parabolic reflector, and you can imagine that, for example, this is, and these basically these concepts are of course all used in physics. So that's a parabolic reflector. And let's say that it is, if you imagine that, let me do a rough sketch over here. If I imagine that it's a parabolic reflector in this way, it is 20 centimeters in diameter. Okay, so let's suppose that the parabolic reflector is, I will draw this line over here, and draw this line over here, and let's suppose that this is the reflector. Seems to be a good, something like that. Parabolic reflector. So then I have to make it symmetric, meaning that I go 1, 2, 3, 4, and 5 units up, and 1, 2, 3, 4, and 5 units down. And then I have to kind of down here, and then up here. Then I clear this up a little bit. And this seems to be okay. Now I'll clear this up as well, and then I will do another axis here. Okay, so let's say that this is the parabolic reflector, and I think I should have done this a little better than this. So let's suppose that this is exactly at the origin, and if this is the x-axis and if this is the y-axis, it says that the reflector is 20 centimeters in diameter. So the diameter must refer to basically this thing, this distance over here. Well, this is not exactly what I was looking for. I'm going to have to do this again. So let's say that that's the case, and this distance is, and this distance over here is 20, or d is equal to 20 centimeter in diameter. And 5 centimeters deep, meaning that you can imagine that this distance over here is 5 centimeter. You want to find the focus. So what that means is that if this is, okay, I got this solution. Okay, so basically, if we assume that this is a parabola, you see that at this point, let's say for example at this point over here, at this exact point, your basically the height over here, so if this diameter is 20 centimeters, then of course this distance is going to be 10 centimeters. 10 centimeters. So the coordinates of this point would be 5, 10, for example. 5, 10. And so this point is actually on the parabola. And we said that basically the equation of this orientation of the parabola is basically y squared is equal to 4ax is equal to 4 times ax. So now if this parabola goes through this point 5, 10, then you can write 10 squared is equal to 4 times 8 times 5, which means that 100 is equal to 20 times a, which means that a is equal to 100 divided by 20, which is equal to 5. So your a is equal to 5. So if a is equal to 5, so then the equation of this parabola becomes, basically y squared is equal to 4 times y is equal to 20x, and the focus becomes basically and the focus becomes basically 5, 0. Or you can say that the focus is actually 5 centimeters. That you can say as well. The focus is 5 centimeters. So if I go back to the and the answer that they have given here is that the focus is at the midpoint of the given diameter, which makes sense because the focus is exactly over here at the midpoint of the given diameter. Okay, so that's basically that. Now we have another question over here, which is an arc is in the form of a parabola. An arc is in the form of, so an arc is in the form of a parabola. With its axis vertical, with its axis vertical. So the arc is 10 meter high and 5 meter wide at the base. 10 meter high and 5 meter wide at the base. How wide is it? 2 meters from the vertex of the parabola. How wide is it? 2 meters from the vertex of the parabola. Away from the vertex of the parabola. Okay, so so I can imagine that, for example, this arc is in the form of a parabola, meaning that, for example, you could with the axis vertical. So if the axis is vertical, I can imagine that, for example, this is, for example, the arc, for example, or something like this. Now if the arc is in the form of a parabola with its axis vertical, something like this, and 10 meter high and 5 meter wide at the base. And I don't understand what that means. So I suppose it would be something like this. And of course, if I imagine that, let's imagine that this is your arc, something like this. Okay, so that means that 10 meter high would be this height over here. This would be 10 meters and 5 meter wide at the base. So this width over here is 5 meters, and okay, so how wide is it at 2 meters away from the vertex? So what we need to do, 2 meters away from the vertex would be, for example, somewhere over here. If, for example, let's say that if this is basically 2 meters, then what is this width over here? So in order to find basically the width of the parabola at this point, at this height, basically we need to find its equation first. And so a parabola in this configuration the equation of that parabola can be written as x squared is equal to 4ay. Now you see that the parabola, for example, at this point goes through the point, or at this point, for example, goes through basically, if this is 5 meters, then this distance over here is basically 5 divided by 2, which is 2.5, or I can write 5/2. So this point, the x coordinate of this point would be 5/2, and the y coordinate of that point would be 10. So then this parabola actually goes through this point, meaning that's 5/2, 10. So then I can write 5/2 whole squared is equal to 4 times 8 times 10. 4 times 8 times 10. Or 25/4 is equal to 40A. Multiply by 4, you will get 25 is equal to 160A, or A is equal to 25 by 160. X squared is equal to 4ay. So if this point is basically 5 halves, and then the height is 10. So 5 halves whole squared is equal to 4a times 10. 25 fourths is equal to 40a. So a is equal to, or you can say 25 is equal to 4 times 4 is equal to 160a. So a is equal to 25 by 160. So 160 divided by 5 is equal to 3 times 5 is equal to 15, 10, 32, 2 times 5 is equal to 10, 32, divided by 5 is equal to 32, and this divided by 5 will get 5 by 32, so a is equal to 5 by 32. Now the equation of the parabola becomes basically 4ay. X squared is equal to 4ay, and a is equal to 5 by 32, so x squared is equal to 4 times 5 by 32 times y, and divide by 2 you'll get 2, divide by 2 you'll get 16, 8, 1, so 5/8 y. X squared is equal to 5/8 y. So now basically you have the equation of the parabola. Now if y is equal to 2, then what is the value of x here? So then x squared is equal to 5/8 times 2. So 2 and 4, x squared is equal to 5 fourths, and x is equal to plus or minus square root of 5 divided by 2. So that means that basically now the question was at how wide is it? So that means that, so now at this point it's going to be positive square root of 5 by 2. Over here you have negative square root of 5 divided by 2, and the height is 2. So then the width of this width over here would be, so then you can basically say the width at height 2 meters would be 2 times basically square root of 5 divided by 2, square root of 5 divided by 2, which is equal to square root of 5 meters. So question number 2 would be, and square root of 5 is basically 2 SQRT of 5 is equal to 2.236, which is approximately 2.236 meters. And that is the answer, 2.23 meters approximately, which is the correct answer here. Now, question number 3 is question number 3 is the cable of a uniformly loaded suspension bridge hangs in the form of a parabola. The cable of a uniformly loaded suspension bridge hangs in the form of a parabola. The roadway, which is horizontal and 100 meters long, is supported by vertical wires attached to the cable. The longest wire being 30 meters and the shortest being 6 meters. Find the length of a supporting wire attached to the roadway 18 meters from the middle. So it says the cable of a uniformly loaded suspension bridge hangs in the form of a parabola. The roadway, which is horizontal and 100 meters. So I don't really know how a suspension bridge works. So I do need to take a look at some pictures probably. The blueprint of a suspension bridge, for example. So over here you have something like this, for example. Let's take a look at one of these pictures. So this you can think of this as the cable, and you can think of this as the road that we are talking about. Now the question is that the cable of a, I don't really know if these are cables. Yes, these are cables. As you can see here, it says cable. So if I assume that these are cables and this is the road, so it hangs in the form of a parabola, as you can see over here, like this. And the roadway, which is horizontal and 100 meters long, is supported by vertical wires attached to the cable. Okay. The longest wire being 30 meters and the shortest 6 meters. They do need to give you some sort of diagram, otherwise how am I supposed to understand this? Okay, so let me find some diagrams for this. I'll be back in just a few moments. Okay, so here is the problem along with the solution and everything. Of course, I'm not going to read the solution here, but I'm just going to use this diagram in order to show to understand the problem. That's all I'm going to do. Otherwise, using this description, it's not easy to understand. So it says that the cable of uniformly suspension bridge hangs in the form of a parabola, which must be this cable over here. The roadway, which is horizontal and 100 meters long, is supported by vertical wires attached to the cable. This thing over here must be the road, and then the longest wire being 30 meters and the shortest being 6 meters. So this is basically that. So now they've taken this as the x-axis and this as the y-axis. This line as the y-axis, this line as the x-axis. You want to find the length of a supporting wire attached to the roadway. So it seems that there are all of these wires all across here, meaning that this the cable, which is in the form of a parabola, is just connected to this road using all of these supporting vertical wires all along, basically. And as you just keep going, basically the lengths of the wires, of course, vary depending on where you are along the road, for example. So you want to find the length of a supporting wire attached to the roadway 18 meters from the middle. 18 meters from the middle. Okay, so that's something that we can do now. Well, at least I understand what the problem is, so we can solve it. So you have basically this sort of thing going on. So let's say that you have I don't know, let's say 1, 2, 3, 4, 5 units over here, and you have 1, 2, 3, 4, 5 units over here. And then I go probably and you can go this high over here, and then connect, connect this point over here, and connect this point over here. Okay, and then what I'm going to do is that I'm going to erase this thing, and so this is the cable that we were talking about. Now there is a road down here, and that road is over here in the form of a, of course you could use another color over here to show that these are different from what we were doing over there. And then this is the road. This distance over here is 30 meters. This distance over here is 100 meters. It's 100 meters. And this distance over here is 6 meters. And you want to find the length of such a cable. So these are all cables that are hanging from this cable to the road. So you want to find the length of the cable that is basically 18 meters away from the center here. So this is your center, and you want to find the length of the cable that is 18 meters away from the center. So the way that you can find it is that, first of all, in this coordinate system, of course, the height of this point is not 30. It's going to be 30 minus 6, which is equal to 24. So the coordinates of this point would be, the x coordinate would be, of course, 50, 24, because this distance over here, if this is 100, then this distance over here is going to be 50 meters. And so then there is a 6 meters over here, so, and the whole thing is 30 meters, so this becomes 24 meters. So 50, 24. Now this parabola, you can write the equation of this parabola as x squared is equal to 4ay. X squared is equal to 4ay. So what that means is that then if it goes through this point 50, 24, you can write basically 50 squared is equal to 4a times 24. 4a times 24. That is 2500 is equal to 4 times 24 is equal to 24 times 4, 16,1, 96 times a. And so a is equal to 2500 by 96. And that is 2500 divided by 96 divided by 2, 45, 48 divided by 2, 1250 divided by 2, you'll get basically 500, and then 250 is 125, 625, 24. You cannot divide by 4 anymore. You cannot divide by 2, you cannot divide by 5. So your a is equal to 625 24ths. So now, since that is the case, you can write the equation of this parabola as x squared is equal to 4 times 625 by 24 times y. Now this gives you a 6 over here, and a 4 is 1. So then x squared is equal to 625 sixths times y. This is the equation of your parabola. Now what you want to do is basically you want to go 18 meters away from the center. That means that your x is equal to 18. And now if your x is equal to 18, then you can write 18 squared is equal to 625 divided by 6 times y. 18 squared is equal to 18 times 18, 64, and 8 plus 6 is equal to 14, 0 and 18, and you have 4, 12, 324. You have 324. So 18 times 18 is equal to 324. So 324 is equal to 625 over 6 times y. And so y is equal to 324 divided by this, or you can write 324 times the reciprocal of this, which is 6 by 625, which is the same thing as 324 times 6 is equal to 24, 2, 14, 1, 19, 1944 by 625, 1994 by 625. That is your y. So that means that 18 meters away from the center, your height is going to be this in meters. And of course you have 6 meters down here, because the cable has to be attached to this someplace down here. So then the total height is going to be 1994 divided by 625 plus 6, which is equal to basically 625. 1994 plus 6 times 625 times 6 is equal to 33, 15, 1, 36, 37, 3750, 3750 plus 1994 equal to 4. 5 plus 9 is equal to 14, 1. 8 plus 9 is equal to 17, 1, and that is a 5. So that is equal to 5744 by 625. And if you do this division, you will get 5744 divided by 625. You will get 456 times 625 times 6 is equal to 33, 12, 15, 1, 37, no, 8. 8 times would be 48. 9 times would be 54, I suppose. So it's 625 times 9 is equal to 45, 4. 18 plus 4 is equal to 22, 2. 54, 56, 56, 25. So 9 times would be 56, 25. And that's a 6, that's a 15, 14, and 14. I'm sorry, I made a mistake there. I did make a mistake there. Okay, so over here, this is a 6. So 14, 13, and 14. So 9 plus 5 is equal to 14. 13 minus 2 is equal to what? No, I have made a mistake here and we need to go back. Okay, so over here I have to start over here. So meaning that this is a 3 and this is a 14. So 14 minus 5 is equal to 9, 1, 1, so that's 119. So it's going to be 9 point something in meters, I suppose. 9.1 meters, 9.11 meters is the answer. So that's basically the answer there. So the next question that we have is okay, so the next question is an arc is in the form of a semi-ellipse. So you have an arc in the form of a semi-ellipse. It is 8 meter wide and 2 meter high at the center. So 8 meter wide and 2 meter high at the center. Find the height of the arc at a point 1.5 meter from one end. You want to find the height of the arc, the height of the arc at a point 1.5 meter from one end. Okay, so now this is simple and basically I don't need a diagram to understand it. So the arc is in the form of a semi-ellipse. So a semi-ellipse, an ellipse would be basically something like this. An ellipse would be something like this, for example. Somewhere over here, of course. And somewhere over here. So if this is suppose that this is your ellipse, and so let me draw the ellipse this way. Okay, and then we can basically erase this part because we're looking for a semi-ellipse. And so it is 8 meters wide, so that means that this basically this distance over here is 8 meters. This is 8 meters and 2 meters high at the center, and this distance over here is 2 meters. You want to find the height of the arc at a point 1.5 meter away from one end. So 1.5 meters. So if we take this as 4 meters, then this would be some around this part over here. So if I assume that this is, for example, 1.5 meter, you want to find this height over here. And in order to do that, you want to basically, we do need to go back to the ellipses and read a couple of things about ellipses, because I have actually forgotten how they exactly were. Okay, so an ellipse has basically two foci. So basically an ellipse is something like this. You have, let's suppose that this is an ellipse, and so this would be an ellipse. Go back a little bit. So basically an ellipse, we said that we had these two foci over here. Let's call this, for example, F1, and let's call this F2. And if you take any point on the ellipse, these two distances, for example, if I call this P, then PF1 plus PF2 would be some constant, meaning that if I take this as P1 and P1F1, P1F2 would be equal to this distance over here. This is P2, this would be equal to P2F1 plus P2F2, and so on and so forth. So this is an ellipse. And so this point, as you know, is the center through the foci of this. It's called the major axis. This is called the major axis. This is called the major axis. This is called the minor axis. The minor axis. And the line segment through the center and perpendicular to the major axis called the endpoints of the axis are called the vertices of the ellipse, and these are the vertices of the ellipse. So we took basically this distance over here, we took it as the semi-minor axis, and this distance we took it as B, and of course by the same logic this is also equal to B, and then we took this distance over here as A. This distance over here we took as A, and by the same logic, same distance we took as A. So this is 2A, this is 2B, And of course this distance over here, is taken as 2c. And that means that this distance over here is then c. So that is basically an ellipse. And there was some relationship between the semi-major axis, semi-minor axis, and the distance of the focus from the center of the ellipse, and the distance of the focus from the center of the ellipse. So this relationship, we basically established that this relationship exists between between AB and C. So you have A squared is equal to B squared plus C squared. This relationship is also there. And then we talked about the eccentricity of an ellipse, which is not very important here. Now we talked about two kinds of ellipses in total. And what we said was that so basically we talked about two kinds of ellipses here. We said that basically if you have basically we derived the equation of two kinds of ellipses, actually one of them, but the other one you could derive on your own if you want to. So if you have this ellipse over here in such a way that the major axis is along the x-axis, so if this is the x-axis and of course is the major axis of the ellipse, and if this is f1 and if this is f2, then this point becomes basically a comma 0. This point becomes negative a. Let me write these in a different color. This is a comma 0. This point becomes negative a comma 0. This point becomes b comma 0. This point becomes negative b comma 0. This point becomes basically c comma 0. Actually, this is 0 comma b. Made a mistake here. These are different because you are on the y-axis. So this is 0 comma b, and this is 0 comma negative b, and this is c comma 0 negative c comma 0. These 2 points. So in this case, basically, what we found was that x squared by a squared plus y squared by b squared is equal to 1. This was the equation of this ellipse over here. And also what we found was that if you have an ellipse like this, something like this, for example, then these basically these points, let's say that these are your foci f1 and f2, for example. So this point over here would be at 0 comma a. This point would be at 0 comma negative a. This point would be b comma 0. This point would be negative b comma 0. And this point would be at 0 comma c. This point would be at 0 comma negative c. And the equation of this ellipse is x squared by x squared by b squared plus y squared by a squared is equal to 1. This is the equation of this sort of ellipse, where the major axis is along the y-axis. So this is all that we said about these ellipses, and there was some other things over here that we talked about as well. For example, the length of the lattice rectum, which is basically this line segment over here, from here all the way up to here. This is called the lattice rectum, and the length of this lattice rectum, we found it to be basically 2b squared by a, 2 times b squared by a. This is the length of the lattice rectum. Now, and of course you know that the eccentricity of an ellipse is equal to c by a. That is some definition that is used for most of these conic sections. Now the question that we have here is that we have this, now we have this basically situation over here, and we want to find out a little bit about this semi-ellipse that we have over here, which is basically half of an ellipse. So first of all, we need to find the equation of the ellipse, and so the equation of this ellipse can be written as x squared by a squared plus y squared by b squared is equal to 1. And you see over here there is a point basically I know the y coordinate, the x coordinate over here, and the y coordinate. So I know my a, I know my b. So this tells me that my b over here is 2, b is equal to 2, and my a is equal to 4, because this distance over here all the way up to here, this distance is 4, half of 8. So that means that my a is equal to 4. So then I can write x squared by a squared by 16 plus y squared by b squared, which is equal to 4, is equal to 1. That is the equation of this. That is the equation of this ellipse. Now, what you want to do is that you want to know at this point what is the height over here. So the x coordinate of this point over here becomes, for example, becomes 8 minus 1.5, right? This is 8 meters and this is 1.5 meters, so the x coordinate of this point becomes x minus 1.5, which is 6.5. So if x is equal to negative 6.5, or you can take it at the other end, write it as positive 6.5. Doesn't make any difference, because your ellipse is basically symmetric. So you can write negative 6.5 whole squared, negative 6.5 whole squared divided by 16 plus y squared divided by 4 is equal to 1. And 6.5 whole squared is equal to basically 65 times 65, and you have 2 decimal places there. The negative sign will be a positive sign because you're squaring it. 5 times 5 is equal to 25, 2, 5 is 30, 32, 0, 6 times 33, 36, 39. So you have 5, 2, 12, 1, that's 4, and 2 decimal places, 42.25. That is 42.25 divided by 16 plus y squared divided by 4 is equal to 1. Now, you need to basically add these together. So 16, 42.25 plus 4y squared is equal to 1, which means that 42.25 plus 4y squared is equal to 16. Is equal to 16. Now, if I take this to the other side, I will get 4y squared is equal to 16 minus 40. .42.25 and 42.25 minus 16 is equal to what? 0, 0, and then you have 3, 12, so 6, 26.25. That's 26.25. That's negative 26.25. Is equal to 4y squared. Why is it giving me a negative, this answer? You see over here, if I write, I can write a y squared is equal to negative 26.25 divided by 4, which is a negative number, and that gives me basically, that doesn't give me any real roots. Oh, okay. Of course it doesn't give me any real roots, because no such x really, your function doesn't have any real output over here. I'm just multiplying, I'm just calculating my output as at negative 0.6. At negative 0.6 there is nothing over here. That was my mistake, I'm sorry. I didn't, basically this distance over here is actually 4. So 4 minus 1.5 is equal to 2.5, of course. 32.5. So I have to take x as negative, basically 2.5. If x is equal to negative 2.5, 3, 4, okay. So over here, basically your x is negative 2.5, because this distance is actually 4 meters. This 8 meters refers to basically one end to the other end. So anyway, so I can write here basically negative 2.5 squared, whole squared, divided by 16 plus y squared over 4 is equal to 1, and basically 2.5 times 2.5 squared, the negative sign is not a problem, but 2.5 squared is basically 25 times 25 with 2 decimal places. 25 times 25 is equal to 625, and that would be 6.25. So that is 6.25 divided by 16 plus y squared divided by 4 is equal to 1, which means that 6.25 plus 4y squared is equal to 1, which means that 6.25 plus 4y squared is equal to 16, which means that 4y squared is equal to 16 minus 6.25 is 9.75. 9.75. 16 minus 6.25, let me check here. 16 minus 6.25, 9.75. And y squared would be equal to 9.75 divided by 4. So the square root of 975 is equal to 5 square root of Okay, so there is something important here about taking the square root of these decimal numbers. I'll pause this video here, and I don't know which question this was, but I will pause this over here, and I will come back in just a few moments. We'll finish this, and then we'll continue in the rest video. We'll continue the rest in the next video. Okay, so now about basically what you have over here is y squared is equal to basically this value, which means that y is equal to the square root of 9.75 divided by 4, which is the same thing as basically the square root of 9.75 divided by 2. Now, of course, taking the square root of 4 is not that big a deal, but taking the square root of 9.75 is I mean, if you want to do it with a calculator, it's easy. You just enter your number over here and you'll get the square root of 9.75. But if you want to do it on paper, you need to know the process. And let's walk ourselves through the process to learn basically how you take the square root of a decimal number. So for example, let's say that you have 25 times 25 times 25, which is equal to 625. If you have 625, if you take the square root of 625, it will give you basically, taking the principal square root, it will give you basically 25. Now, if you have basically 2.5 times 2.5, you will have basically 6.25. So that means that the square root of 6.25 is going to be equal to 2.5. And I can show you using a calculator as well that the square root of 6.25 is equal to 2.5. So what that means is that if you have two decimal places over here, the answer that you will get over here will have one decimal place. If you have, for example, let's say, if you have 4 decimal places over here, you will have 2 decimal places over here. If you have basically 6 decimal places over here, you will have basically 6 divided by 2, which is equal to 3 decimal places over here, and so on and so forth. Meaning that every 2 decimal place, of course, will be translated to 1 decimal place. So that's basically that is basically why if you have if you had basically the square root of 975, the square root of 975 is equal to basically 5 square root of 39. 5 square root of 39. Now that you have the square root of 9.75, this will be this over here. You would get basically one decimal place, and your one decimal place, you need to add it to this number over here, which means that this is going to be 0.5 times the square root of 39, or basically 5/10 or something like that, which is basically, if you write the square root of 9.75, it will give you 5/10, which is equal to 5/10 the square root of 39, and 5/10 is basically 1/2, which is equal to the square root of 39 divided by 2, which is basically this answer over here, as you can see. So this is about taking the square root of these numbers. So what that means is that then if y squared is equal to this number, then y is going to be plus or minus this number, or plus or minus this number, which is equal to now we said that the square root of 5 square root of 39 is the square root of 975. So over here we have 5 square root of 39. So this is, we write the rest over here. So this is 5 square root of 5, basically with the decimal place 0.5, square root of 39, and plus or minus that divided by 2, which is the same thing as basically 5/10 square root of 39 divided by 2 plus or minus that, which is equal to 5 divided by 20 square root of 39, and that is equal to basically 1/4 plus or minus 1/4 square root of 39, which is equal to the square root of 39 divided by 4. That is basically the height of the semicircle, the semi-ellipse at this point over here, which is basically, let me go over here to the example that we had. It was example number 4, and this value is basically square root of 39, square root of SQRT of 39 divided by 4, which is equal to 1.56 meters approximately, which is basically this value that we've gotten over here, plus or minus 1.56 meters approximately. That is the answer over there. Okay, so I'm going to end this video here, and in the next video we will continue with basically example number number 5. I'll see you in the next video.